Okie dokie. So we are going to revisit 215, okay? Because some of this stuff, there's a fine line sometimes between doing too much and making things confusing and then not doing enough and you not understanding how to work all the questions that might come up. So for this particular topic, I was trying to, because we could go pretty deep in this and we can make it pretty crazy, but I was trying to make it just kind of exactly what you needed and this would all be fine. And I kind of regret not doing a couple of things with you. But at the same time, I don't regret not doing them that day because I think it would have been all way too much anyway. So let's just talk a little bit. We're going to come back in just a minute and we are going to, so the first thing I struggled with, I think I told you that when we did this one, was I was going to show you how to actually create this equation. And then I thought better of it because I thought there's different ways to do this. And this would most likely be a multiple choice type question. But if I change the answer choices, we may not be able to work it the exact same way that we did. Or even if we could, maybe the numbers would be weirder and it just wouldn't work out too well for us. So we're going to come back and revisit that one in just a minute. Because the first thing we're going to revisit is this. Now remember, when you look at this looks horrific, right? But it wasn't that bad. It just looks bad because we got logs written all over the place, right? But what this was that we were finding a linear equation for this semilog plot that really represents an exponential function. Yes? Right? So when I look up here, and we looked at, we should know what an exponential equation looks like, right? That one, yes, we absolutely should know. I know this one looks weird because it's got logs written all in it, but remember, all it is the equation of a line in slope-intercept form. And yes, you can just kind of remember what it is, but I'm also going to show you where it comes from, because worst case scenario, you might have to develop it if you're not sure if A or B, like which one was which, that sort of thing. I think one way to remember it is that you got a log for both of these, but where you usually put B, that's not where B is. That's going to have to be A and that's going to have to be B. That's definitely one way to do it. But I also think showing you where it comes from might also help you realize nobody's just willy-nilly throwing logs around and making this stuff work, okay? So on the back of this piece of paper should be blank. So if you fold it up, so it's like upside down like we're used to, we are going to come up with this. Because again, if you had to, you could, because you have the skills to be able to do it. All right? Thank you. Victor, are you here? Yes. Thank you. Great. So here we go. So we know that an exponential equation looks like that without any translations or anything in it, right? So if I want to take this and we do a log with it, right, then just like any other equation you ever do anything algebraically with, whatever you do to one side, you have to do to the other, right? So on this one, I'm going to take the log of both sides. So this is going to give me the log of y equals log of a times b to the x power. Okay? So whatever I do to one side, I do to the other. All right, so now on the left, log of y is just going to hang out and be log of y. On the right-hand side, I have this exponent x. Can I bring x out in front right now? No, because it's not on the whole thing, right? Can I split that, though? Yes, okay? So that means I would get the log of a plus the log of b to the x. All right. Everybody okay with that so far? All right, so now can I bring x out in front? Yes. So now I get the log of y equals the log of a plus x times the log of b. All right, now let's talk parentheses a little bit before we move on any farther. The parentheses I have up there right now absolutely necessary. So it doesn't look like I'm taking the log of a and then multiplying that times b to the x, right? The other places where I don't have them, sometimes I do and sometimes I don't, because sometimes you'll see them and sometimes you won't. And you don't have to have them, but it's not a bad idea and it's not wrong. So if there was parentheses on all of these, that would be totally fine. Plus, since x is in front of the log of b right there, I didn't need parentheses around the whole thing. However, if we look back at how this is actually written right here, you'll notice a couple of things. We're basically at this step, except that these two terms are flipped around and they have the x behind it. That's why they have parentheses around the whole thing. And since it's a semi-log plot, it's really just the log of the right-hand side. But remember, when we have this, and that's what we're coming up with, when we were actually substituting stuff in and we had our y, we had to do the log of the y, right? That's why the logs there just like disappear. So if I wanted to write this in the actual form as what they have on there, I would flip that around and get y equals the log of b times x, because that's like m times x, right? Put m, sorry, times x plus the log of a. So if you had to come up with the equation yourself, technology glitch, aka somebody hit the wrong button and cleared everybody out. So we will re-enroll later. All right. So do you see how this was just some very basic log properties? Once again, it's kind of bad just because log's written over and over again, but we could come up with that. Yes? Here's the other thing you have to remember about testing is that if we need this, because we're going to need this basically to redo this question. And on this question, they don't give, and we're going to pretend like it's not multiple choice because we already know what the answer is. But again, if we had different answer choices, we might want to discover it in whatever. It could be written in such a way. And so it's not here, and if you're not sure where the logs go or what it looked like, then maybe you skip this problem for now. You go on through the test, then you get a question like this, where it actually gives it to you, and now you have no question, right? Could always be written in another question, right? That's true for any kind of test. You might have some other information in another question. Okay, so we are basically going to do this kind of thing. We are going to do it a little bit differently than this one, because you can do them in different ways. We could still find the slope and do all of that. But let's go back over here, and we're going to pretend like we don't know the answer, and we don't have any answer choices, and we are going to come up with this equation, okay? So my equation that we just got on that other page, log of y equals the log of b times x plus the log of a. Right? That's just what came from that other page. That's what we just discovered on the back of that piece of paper. And now, just like any other equation we ever do, we can substitute in some unknowns. This is on the front part of the notes, the first page, if you're flipping around. First page of the notes on the front. Right here. Yeah, this is the front of the notes. Last question. Okay, so I'm going to substitute in an ordered pair. Okay, I have 3 ordered pairs written here. That's most likely what we also did in class, but I don't know which flip chart I saved and which one, but you should probably have at least 3 written down. Of these 3, I would say probably the one that might make my life easiest is the one with the 0 in it, right? Yes, I could use 430, but why do that, right? So I'm going to use this, and so log of y, so that means this is going to become log of 2 equals the log of b, which we don't know, times x, which is 0, plus the log of A. And that made things really nice, wouldn't you say? Because what happens to this term? It zeroes out, right? 0 times that just zeroes out. That means that the log of 2 equals the log of A. So what does A equal? 2. Okay, we good with that? All right, so now I'm going to go on the other side, and I'm going to rewrite what I have in green, but I'm going to add in that log of 2 instead of log of A. So I have the log of y plus, not plus, oh goodness, let me do it correctly, equals the log of b times x plus the log of A. Right? So, log of A. Shoot, the whole reason I did that was to make that log of 2. Now my brain is acting more like it's a Monday than a Friday, so. All right, everybody with me so far? Everybody understand where everything came from? Okay, so now I'm going to substitute in a point again. It's not going to do me any good to substitute in the same point I just substituted in, right? Because I'm just going to get the same freaking thing, and that's not what I'm looking for. Instead, I would use another one. Again, I could use 430, but why make things more complicated? I think I'm going to go with 1/4. So that means I would get the log of 4. The log of 4 equals the log of b, which I don't know, times x, which is 1, plus the log of 2. So now log of b is my only unknown. We okay with that? What would I do next? Subtract the log of 2. Good. So I'm going to have the log of 4 minus the log of 2, and that equals the log of b. Now, what is the log of 4 minus the log of 2? Log of 4 over 2, which is 2. So, little side note here. Let's just take a quick second and come over here. The log of 5 minus the log of 3 does not equal the log of 2. Do we agree with that? Okay. Instead, this actually equals the log of 5/3 because you're not literally subtracting the arguments, right? So I just want to make sure, because of the way 2 and 4 are related to each other, that when we get the log of 2 there, you're not thinking it's because we did 4 minus 2, okay? Just reminding you that this is what we're doing. This came up in calculus day before yesterday, and it was rough. Let me just put it that way. So we can't forget this. We're still going to need it. So I get the log of 2 equals the log of b. Therefore, b equals 2. So then what we know about exponentials is y equals a times b to the x. Because log of 4 minus the log of 2 is the log of 2. It's the log of 4 over 2. You divide. Okay, so then for this particular question, your y is your p of t. We just figured out what a is. We just figured out what b is. They're not always the same number, by the way. And we don't have an x, we have a t, and that's what makes it this answer here. Okay? So that's how you actually get that equation. Now, another little side note about this is that the reason we use the common log, because what's the base of the log we were using? 10. And we were using that one because this is logarithmically scaled on a base 10. If my proportional pieces, if it was base 2 or base 5 or base whatever, that's the base you would use as the log. Okay? We okay on that? All right, so baby stepping through it. And if we come back and revisit this, like right now on this test, I don't plan on giving you crazy difficult questions because I want to make sure that you understand the basics. That doesn't mean that crazy difficult questions aren't down the road, all right? So just make sure you understand this. You still may have to write an equation or something, but I'm not going to make it like way out there at this point because I know we haven't had it in our brains very long. Okay, we good with that? All right, any questions at all? Yes? Yes. So if this was 2 to the first, 2 to the second, 2 to the third, that type of thing, then yes, we would have it spaced. It would be log base 2 or log base 5 or log base whatever. Okay. We're okay with that? We're good? Any other thing? All right, good deal.